Physics in the Flesh is back with another vectors example, number 6 in two-dimensional kinematics. Three vectors are shown in the figure below. Their magnitudes are given in arbitrary units. Determine the sum of the three vectors. Give the resultant in terms of A, the components, and B, the magnitude and angle with the x-axis. So here we go. Here's our problem. Here's our diagram. We've got three vectors, A, B, and C. The magnitudes are given next to the actual vector, and the angles with respect to the x-axis is given if necessary. So for part A, we're asked to determine the sum of all three of these vectors in terms of their components. So the first thing you want to do with any one of these problems, especially when they're off on angles like this and they're not so much in the northeast-southwest direction, you want to determine the components of each vector. For instance, A has x components and it has y components. If I was to take A and drop a straight vertical line down to the x-axis and make a right angle, I can have a component AY on this side and I can have a component AX on the bottom. And I know the hypotenuse of this right angle triangle, it's 44. That's the length of the vector. So if you actually look at it for A, let's say I draw it on the side here just for illustrative purposes, you've got your right angle, you've got A, you've got AY, and you've got AX. Now notice based on the graph, AX and AY are both in the positive direction. If you remember based on vector addition, if this is one vector and it's equal to the sum of these two, that means AX needs to be going in this direction and AY needs to be going in this direction, tip to tail. Right? So AX plus AY equals A. And we know this angle to be 28 degrees. So just for example purposes, and I'm only going to do this for the first triangle, and then the other ones, you'll get the hang of it. Okay, so let's say I wanted to determine AX. Okay, so based on this right angle triangle, AX is adjacent to the angle 28 degrees. So, and I know the hypotenuse is 44.0. Okay, so adjacent and hypotenuse, when you look at SOHCAHTOA, adjacent hypotenuse is part of the cosine function. Okay, so we're going to say cosine of 28 degrees is equal to adjacent, which is AX, over hypotenuse, which is A. We are looking for AX, right? So what we're going to do is try to get it by itself. Right now, AX is being divided by A, so we have to do the opposite operation. We need to multiply both sides by A, okay? So that cancels out the A on the right, leaving us with AX. So AX is equal to A cosine 28 degrees. And you know what? You're going to see this similar setup for every single right angle problem you do where you try to figure out the sides. Okay. You see how AY is opposite to this angle? By symmetry, we can actually say that AY is going to be equal to A sine of 28 degrees. And this is how we can determine all of these relationships. So that was just a brief example for you to see how to do it. I'm just going to go ahead and dive right in. So remember, we're trying to add all these three vectors together, A, B, and C. And we're going to try to find the resultant in terms of components. Whenever you have a problem like this, just break up each and every vector into its components, X component and Y component. If you're dealing with 3 dimensions, then you break it up into its Z component as well. Okay, so actually let's keep that on the screen there. Okay, so I'm going to go ahead and start finding the components. And I'm going to do the X components first. So let's do X. Okay, so the X component for A, so AX is equal to the hypotenuse, which is 44.0, times the cosine of that angle, which is 28.0 degrees. Okay. And when you calculate that out, you're going to get 38.9. Okay, so there should actually be a 0.0 there and a 0.0 there, so we have a bit more information. Okay, 38.9. Now for B, okay, so BX, similar thing. When you look at B over here, if you were to drop a vertical line down to the negative x-axis, you would make a right angle here, and the x value is going to be the hypotenuse times the cosine of the angle. Okay, so we're going to do 26.5 cosine of 56.0 degrees equals 14.8. Now, there's something here that you have to pay attention to. You remember how here I mentioned that the AX was in the positive X direction and the AY was in the positive Y direction? You can tell that by looking at the diagram, right? This X is in positive, this X is in the, Y is in the positive. But for B, right, if you were to draw the components, you've got a negative X and then you've got a positive Y, making that right angle and adding up to the vector B. Okay, so in fact, this value for B is negative. And this is something you have to determine for yourself by looking at the diagram. Okay, that's how you can keep yourself accurate. All right, so that's for B. And finally for C, for the X component of C, I'm just going to move this up a bit. You know what, let's just go up all the way. For C, we're going to find the X component. So again, for C, you can probably again tell by looking at the picture, C is purely in the Y direction. There's no X component. Okay, so we're going to just say 31 cosine of 0 degrees. That's going to be 0. Pardon me, cosine of not 0 degrees. That would be, cosine of 0 is actually 1. That should be cosine of 270 degrees. And the reason why it's 270 degrees, your angle, if you start from the positive x-axis and you rotate all the way around, that's 90 degrees and 180, 270. Cosine of 270 is 0. Okay, but nonetheless, you can see that from the picture anyways. Okay, so we've got our x components. Now let's find our y components. All right, so just like we used cosine to find the x components, we're going to use sine to find the y components. So once again, hypotenuse times sine of the angle, 28.0 degrees, and you're going to get 20.7. For B, okay, so this B is actually in the positive direction. Remember the diagram? So you get 26.5 sine of 56 degrees is equal to 22.0. And finally, CY, well, C is fully in the Y direction. So C is just minus 31.0. And that's it. So we've got our components. We're not quite done yet because these are the components of each individual vector, right? We want to know the components of the resultant. So when you add A, B, and C together, you are going to have a single vector, X, Y, Z, and you need to provide those coordinates, those components rather. Okay, so this is how we're going to do it. Okay, so we're going to say, you know what, just like in our previous problems, we saw that the resultant is a combination of an X resultant and a Y resultant. And that's why we actually started breaking up the problem like this into the X components and the Y components. So what we're going to do is find an X resultant, add all the X's together, and we're going to add all the Y's together, and then we're going to add the resultants together, okay, and see what we get. So going ahead and doing the resultant for the X first, so let me just draw a line there. So resultant in the X direction, essentially what we're doing is we're adding vector A, vector B, and vector C all in the X direction. So that means we're going to do, here we go, 38.9 minus 14.8 plus 0. Okay. 38.9 minus 14.8 plus 0. That's going to be equal to 24.1. And we do the same thing for the Y direction. So our Y, okay, we're going to add the vectors A, B, and C that are in the Y direction. So again, we're going to add these values. We're going to say, you know what, 20.7 plus 22.0 plus negative 31.0. And when you add those together, you're going to get 11.7. Okay. So while R is equal to Rx plus Ry, okay, so this is the final vector, we are just asked in part A to give the components, right? And that's what we've already done. we have the x component, we have the y component. So that's all we need to say. R, the resultant, so therefore, actually let's put a therefore in front. Therefore, R is equal to 24.1, comma 11.7. And that is the answer for part A. Okay? So moving on to part B, we have to give the resultant now in terms of the magnitude and angle with the x-axis. So this is going to be a snap now that we've already figured out the components. Okay, so let's go ahead and do that. So we have our resultant. Now for part B, let's find the magnitude. Right? So what we need to do in order to find the magnitude from the vector is just this. You put absolute value symbols around your vector, and it's Pythagorean theorem again. So it's r squared equals 24.1 squared plus 11.7 squared. And of course you can go ahead and forego that step. You can just say, you know what, r is equal to the square root of 24.1 squared plus 11.7 squared. And when you do that math, when you take the sum here and you square root it, you're going to get the value of 26.8. So that is R. Okay, so let's underline that. Now, in order to find the angle with the x-axis, we have to understand this geometrically. So remember, our x component is 24.1 positive, y is positive 11.7. So if we draw this, what we have essentially is this. We've got a 24.1 in the x direction, and we've got 11.7 in the y direction. There is a 90-degree angle formed at that juncture. And the sum of these two vectors, added tip to tail, you start from the tail of the first vector and you work your way to the tip of the second vector, like this. And our angle theta is going to be from the hypotenuse to the first vector there. Okay, so that's how we're going to find our angle with respect to the x-axis. After all, this is the x-axis. Okay? And we do that using our trusted tan. Okay, so tan theta is equal to opposite, which is 11.7, over adjacent, 24.1. Okay. 11.7 over 24.1 gives you 0.4855, and in order to get theta by itself, we have to do the opposite operation to both sides. To get rid of tan, you have to take the inverse tangent. When you take the inverse tangent on the left, inverse tangent of tangent gives you 1, so we're left with theta on the left. On the right, inverse tangent of the value that I just quoted you, 0.4855, gives you an angle measure of 25.9 degrees. Okay. So there we have our angle. Now we have to interpret this in terms of the problem. Because that's theta right here, that means theta is above the x-axis, right? So therefore, in total, to answer part B, the magnitude of R is 26.8, and its direction, which we will quote in square brackets, is 25.9 degrees above the positive x-axis. And there you have it, your answer for part B. So just to double check, sig fig count, in our original question we had 3. So let's just pull that back up here. Right? Our angles were quoted to 3 sig figs. Our lengths quoted to 3 sig figs. Therefore, our answer must also have 3 sig figs. And sure enough, there they are. Okay, so that's it for this video, guys. If you enjoyed it, be sure to click that like button and subscribe to my channel so you never miss a video from Physics in the Flesh. It's been a pleasure, guys, and I hope you have a good rest of your day.